Hello viewers, so today we'll talk about CPU and GPU. What is the difference between CPU and GPU? We'll see in detail. So let's get started. So what is CPU? CPU, as we know, it's central processing unit and it's called the brain of computer. So constructed from millions of transistors, the CPU can have multiple processing core and is commonly referred to as the brain of the computer. It is essential to all modern computing system as it executes the commands and processes needed for your computer and operating system. The CPU is also important in determining how fast programs can run, from surfing the web to building spreadsheets. What is GPU? The GPU is a processor that is made up of many smaller and more specialized core. By working together, the core delivers massive performance when a processing task can be divided up and processed across many cores. The clock speed of a GPU may be lower than modern CPU, normally in the range of 500 to 800 MHz, but the number of cores on each chip is much denser. This is one of the most distinct differences between a graphics card versus CPU. This allows a GPU to perform a lot of basic tasks at the same time. So difference between GPU and CPU is GPU is optimized for parallel operations, whereas CPU is optimized for serial operation. GPU has high throughput, but CPU has high clock speed. GPU for fine-grained parallelism and CPU is for coarse-grained parallelism. GPU have low latency in image pipeline, CPU has high latency in image pipeline. GPU has several image processing libraries and CPU has numerous image processing libraries. GPU is better performance per watt and CPU is comparatively low heat output. So CPU and GPU have a lot in common. Both are critical computing engine, both are silicon based microprocessor and both handle data. But CPU and GPU have different architectures and are built for different purposes. The CPU is suited for a wide variety of workloads, especially those for which latency or per core performance are important. A powerful executing engine, the CPU focuses a small number of cores on individual tasks and on getting things done quickly. This makes it uniquely well equipped for job and ranging from serial computing to running databases. So GPU is key to all AI related work, computer vision, supercomputing, and many more things. Blockchain is another example where GPUs can be very helpful. Over the past decade, that is proven key to growing range of applications. GPU perform much more work for every unit of energy than CPU. That makes them key to supercomputers that would otherwise push past the limit of today's electrical grids. In AI, GPU have become key to a technology called deep learning. Deep learning ports vast quantities of data through neural networks, training them to perform tasks too complicated for any human coder to describe. So CPU has low compute density, whereas GPU has high compute density. GPU has high computation per memory access, whereas CPU has complex control logic. CPU has larger caches, whereas GPU is built for parallel operations, many parallel execution unit. Graphics is the best known for parallelism. GPU is for deep pipeline, high throughput, whereas CPU is for shallow pipelines, low latency tolerance. CPU is for newer CPU, have more parallelism, whereas GPU is for high latency tolerance and newer GPUs, which gives you better flow control, scattered and gather memory access, and don't have any one-way pipeline anymore. So CPU have fewer strong cores. It is suited for serial workloads and quick access to system memory RAM. But GPU have thousands of weak cores suited for parallel workloads and can only access VRAM quickly. So CPU is for central processing unit, GPU is for graphic processing unit. GPU has many cores, CPU has several cores, and CPU has low latency, but GPU has high throughput. It is good for CPU is good for serial processing, whereas GPU is good for parallel processing. CPU can do a handful of operations at once, whereas GPU can do thousands of operations at once. So why we need two different type of processor? Everyone is somewhat familiar with CPU, known as the brain of computer. They are composed of millions upon millions of tiny transistors with multiple cores. It is critical for handling the main processing function of a computer. Actions like running the operating system and applications would not be possible without it. The, the CPU is also what determines the general speed of a computer. GPU are more specialized in nature. Originally designed to help with 3D rendering, they can do more processing in parallel. This is perfect for use in graphic intensive applications that rely on displaying dynamic content for gaming or compressing, decompressing, streaming videos. GPU are also being used in many other areas beyond rendering and image processing, like artificial intelligence and Bitcoin mining, blockchain technologies. The main difference between CPU and GPU is how they process the instruction given to them. In human terms, you could say that CPU is master of taking one task at a time, whereas GPU can take many tasks at once. While there are some other work being done things in sequential order other than multitasking. So in summary, we can say the CPU is responsible for the serial processing while the GPU is responsible for the parallel processing of tasks. Thus, for the higher performance of the computer, both CPU and GPU are required. This will make parallel portion of code run on GPU and serial portion on the CPU. If seen individually, both have their own limitation. A CPU has heavyweight instruction sets, slow switch latency, and define Moore's law, while GPU have less powerful cores but can focus on only one task at a time and has limited APIs. So thank you so much for watching today's video, and if you think the video is helpful, do like the video and subscribe to the channel.